let's graph, as it asks us to do so, the square root of x plus 2. Now you should already know what y equals the square root of x looks like. It has its node at the origin, it goes through 1, 1, and it goes through 4, 2, because 4 square roots to 2. Now, using transformations, this plus 2 inside the radical is with the x, and so you know that's going to control left or right, and you know not to go with 2 thinking that's to the right. You should know that that means we're moving left 2 units. So I'm going to take my node here at the origin and move it left 2 to negative 2, 0. The 1, 1 will move 2 to the left, and that 4, 2 will move to 2, 2. And what I'm drawing in now in solid blue is the graph itself of f of x. Now, they want us to answer some questions about f of x. The first question is this a one-to-one function? And the answer is, does it pass the vertical line test? And yes, the horizontal line test? The answer is yes. The reason is, it passes both the vertical line test and the horizontal line test. Now they want us to find the domain in interval notation. Now the domain is where the graph is defined from left to right, and it starts being defined at negative 2 on up to positive infinity. So our answer here will be from negative 2, which we include, on up to positive infinity. Likewise, what is the range? Well, you know the output must be positive for a square root, so the range will be from 0, which we include, on up to infinity. Continuing on with this same problem, we want to find the inverse. If we begin with y is equal to the square root of x plus 2, the first step is to switch the x and y. That will give us x is equal to the square root of y plus 2. Now our goal is to solve for y itself. We're going to begin by squaring each side. We will have x squared equals y plus 2. And then, subtracting 2 on each side, we will have y equals x squared minus 2. Now let's think about this for a second. Here was our original graph, starting 2 units to the left and going up and over like that. Now we have this right here, which is a parabola, which pretty much does not look like the inverse of that original function. These two are supposed to be reflections across the diagonal line y is equal to x. Well, if we turn our head, we can see that this right side matches up, but we don't want this left side here. So what we do when we write our inverse is we say f inverse of x is equal to x squared minus 2, but we only want the right side of it, so we write comma x must be greater than or equal to 0, changing the domain so that we only have the right hand side of this, so that this thing is a one-to-one invertible function. So explain why in this next part. We've written this restriction there. Well, I think I've already answered that here. Let's just say the graphs do not appear to be inverses. We must restrict the graph to the right side. Now, this basically happens whenever the original function is even, or whenever the inverse happens to be an even function, because even functions do not obey the horizontal line test, and therefore their inverses get kind of messed up. We don't have that one-to-one relationship. Now they're asking us in this next part to graph both of these side by side. So once again, here is the original graph, which I will label f of x, and then the inverse has a vertex of -2. It goes up 1 over 1, then over 2, up 4, and there is our parabola. I probably should have hit that point there. There's our f inverse of x. Now, what is the domain of f inverse? Well, looking at the inverse, its x value starts at 0, and so that would be from 0 to infinity. And the range will start at -2 and go upward, and we will have -2, which is included on up to infinity. Now, let's step back for a second here and compare our answers to these two. The domain of f became the range of f inverse, and the range of f became the domain of f inverse when you compare the two of these side by side.